And we're back with ice and rain protection for our King Air 90. So over here in the icing conditions column, these are all the requirements for approved flight in the known icing conditions. So alternate static air, engine auto ignition, and annunciator, 2 of those, 2 engine anti-ice systems, 2 heated fuel vents, just 1 heated windshield, as long as it's the left windshield. Pitot heat, 2 of those, and then 1 each. Pneumatic pressure indicator, stall warning heater, surface de-icer, propeller de-icer, and wing ice light, as long as that one is on the left, of course. Here's where the equipment lives. Pitot, prop, engine anti-ice, and then the boots, windshield heat. For the controls and indicators, controls down here for the engine anti-ice. The actuators in standby or main, they're normally in main. The hot 5 down here, 1, 2, 3, and then 4, 5. De-ice for the boots, single down here and manual towards the bottom. And then the prop heat as well. Indicators, amps here, or prop amps, pressure, pneumatic pressure, and then the left engine anti-ice fail, or the left engine anti-ice is in the on position. For the description of the system itself, we have 7 pilot-controlled anti-ice and de-ice systems. These are all controlled on the left side of the cockpit. Windshield anti-ice, the boots, the inertial separators or engine anti-ice are also known as the ice vanes. Pitot heat, prop ice or prop de-ice, and then the stall warning heat, and then the fuel vent heat as well. Part of the hot 5. Hot 5 would be 2 of these, 1 of these, and then 2 of these. Here's a picture of the pitot heat. Looks like it may have failed here. You got some ice accumulation. For the pitot heat, they're electrically, there's two of them. They're electrically heated, not for ground use, maybe on continuously in flight, as they often are. Stall warning vane, there's just 1 of those. There's just 1 switch for that. It's the leftmost of the hot 5. For windshield wipers, there's 1 wiper for each side, 1 motor. Do not operate on a dry windshield. For the windshield anti-ice, they're independently controlled. There's a wire going through the windshields. Normal heats the entire thing. High only heats 2/3 of it. I have a schematic of that here. So here's the windshield with all the wires going through it. The red is the energized wires. And then with the high heat relay, it drops down to here and then only heats 2/3 of it. Here's a picture of some surface de-ice boots. It looks like these were actuated possibly too early, and so the ice did not break away as advertised. They're pneumatically operated. A vacuum holds the boots closed unless you actuate it. If you, the up position would be single, 6 seconds on the wings, 4 seconds on each of the 3 boots on the tail, and then in manual, they're all inflated as long as you hold it there. The engine air inlet, it's always heated. This is not pilot controlled. It's uses exhaust gases, and then I've got a picture of these tubes that circulate heat through the engine inlet here. Here they are coming in, circle around here in order to keep that guy heated. Not pilot controlled at all. For the engine inertial separators or engine anti-ice or ice vanes, those are in here mechanically, or these are the 2 mechanical flaps that change position in order to prevent ice and FOD from ingesting or getting ingested. So this guy moves over to this down position, and then this guy moves to this up position in order for any sort of ice or other heavy FOD objects to not be able to make the turn right here into turn 1 and continue out onto the pavement or outside the engine nacelle. For the ice vane controls, there's a pilot selectable main or standby. These are most often in main. With visual moisture 5 degrees C or less, you want to turn those on and before you encounter the visible moisture. If this position where you have this right on and off, left on and off, does not agree with where the ice vanes actually are, is when you'll get this engine, right or left engine ice fail. That just means it's not in the same position as that you're commanding it to be. The auto ignition system, left to right arm, this is just above on the left sub panel, right above the ice vanes or the engine anti-ice. Arm those before takeoff, part of the lineup check, challenge and response with the co-pilot. And 413 Golf Alpha, it's the right one that you can often hear in your headset before you run up the engines. And then it automatically turns engine ignition on when the torque is below 400 foot-pounds. Prop de-ice. In the auto position, 90 seconds to cycle for both props. It does one prop and then the other prop. That whole system or the cycle takes 90 seconds. It's 14 to 18 amps, and you can read that in the overhead panel. Wing ice lights. It's the third position up from the right, right next to the nav and recog lights, just to the right of the taxi light. So for normal operations, the wing, tail, control surfaces, props, everything needs to be free from ice and frost. We may use fuel and anti-icing additive in extremely cold. I haven't experienced minus 30 degrees here in Denver, but it's possible. And then use engine anti-ice before visible moisture is accounted. We talked about this above or below 5 degrees C, positive 5 degrees C. That can be read on the just aft of the fuel panel on the pilot side of the cockpit. Before takeoff, the hot 5 are these 5 switches. This is again a lineup challenge and response for 2 fuel vents, 2 pitos, and the stall warning. For limitations, prop de-ice only when the props are turning, please. Minimum airspeed is 140 knots to go through sustained icing conditions, and that would be visible moisture and 5 degrees C or less. During flight, use all these things. So the stall warning, the pitot heat, and the fuel vent are taken care of by your hot 5, and then prop de-ice just to the left of the hot 5, and then the windshield heat on that panel as well. For emergency or abnormal conditions and extreme icing conditions, you don't want to really blow the boots until you have about a 1/4 inch of ice. If ice forms after the protected surfaces, you may be in trouble. When would this happen? Super cooled, large droplet icing is hitting the top of the wing, not necessarily the leading edge of the wing. That area is not heated. Autopilot may mask these control problems as the plane compensates for it without necessarily the pilot feeling any additional control surface pressure. You want to maintain 140 knots, do not extend the flaps, and then be alert for a possible stall from the tail. Quiz time. Question 1, how does the wing de-ice system operate? Engine bleed air, boots, auto cycles. When single is selected, wing boots inflate for 6, tail for 4. Answer is D. Single is 6 seconds and 4 on the tail. Manual, as we discussed, is inflated until unactuated. Question 2, which of the following is not part of the hot 5? We went over this, I think, 3 or 4 times in our presentation, and the answer is D, prop de-ice and windshield heat. Question 3, when is the engine air inlet heated? This is the one that is not controlled by the pilot, therefore continuously whenever the engines are running. Question 4, when extended, the engine ice vanes or engine anti-ice prevent ice ingestion, prevent FOD, both A and B, or ice accumulation beyond the protected surfaces. C, A and B are both correct. And then question 5, which of the following is not true regarding extreme icing conditions? I'll let you read that for a second. Not true would be B. Super cooled large ice droplet icing is not hazardous. It of course is hazardous. Questions, Gary?
Got none.
All right, that concludes our ice and rain protection.